In this section we need to go one step further. We need to use a nice interface connected to OLAMA, and here we can build different things, for example reg applications. In order to do that you need to first understand vector databases, embeddings models, top K results, chunking, and the whole concept of reg, retrieval augmented generation. I will show you how you can optimize your data. You need to make it into Markdown so that the LLM can read it a bit better. Then I will show you all the anything LLM basics, the whole interface, how you can use the models that you installed in OLAMA in another interface named anything LLM. Then we talk about chunk size and overlap so that you can build your own reg application inside of anything LLM. This will be cool and fun. I also want to show you how you can control the behavior of the AI, how you can increase or decrease the top K results for better retrieval, how you can increase or decrease the temperature, for example, how you can set system prompts, and how you get the most out of this reg app. I also want to give you a small overview of the agent capabilities of anything LLM. This will just be an overview because as soon as we talk about agents we need to bring N8N and Flowwise into the game. And lastly I want to give you an LM Studio crash course. LM Studio is also a great application. This is an interface that works outside of OLAMA, so you can download your models without using OLAMA. LM Studio is really great because you have everything included in one ID. And you can also use the model context protocol that we will also do later. So I see you of course in the next video where we talk first of all of course about vector databases, reg and embeddings. You already saw on OLAMA that we have these embeddings models. And these embeddings models are for the reg technology. The reg technology is here to give your LLM additional information, for example about your company. And if you run everything locally, of course this is 100% private. In order to make the concept more concrete and easier and faster to explain, I want to also make a high-level explanation into ChatGPT. But in the next video we will implement all of this of course with local AI. If we want to give an LLM additional knowledge, generally speaking we have two different options. It's either the in-context learning or of course the reg technology. These are, at least in my experience, the best ways. Of course we can also do fine-tuning and a lot of other things, but you already know that we can do this reg technology. And in order to understand the reg technology we need to understand embeddings and vector databases. Because we can simply browse a PDF if we upload it and we can search every single thing out of this file. Of course, you can give context in the prompt, but let's just say you want to give a lot of context. Sooner or later the context window will be reached. If you want to upload like a gazillion PDFs in this context window, the token limit will be reached. I hope you remember what the context window is. As soon as you have too much tokens inside your context window, the LLM will no longer understand what you are talking about. If you go in ChatGPT, for example, of course, on my GPTs, you press create. And then you can use this knowledge here, and here works the reg technology. If you upload files, something cool happens. And these files, they get stored in a vector database. Before they get stored, the embeddings model make them into vectors. And then we can do a search query. And the LLM will simply search your PDF. And now I want to show you exactly how this works. And then of course also how you can make this yourself with every single LLM. So also with open source LLMs. This article from NVIDIA, what is retrieval augmented generation, aka reg. This is a cool article. It's, at least in my mind, a bit too long, but I think this picture is perfect. Generally speaking, this is how it works. First of all, of course, we have a lot of PDFs, a lot of documents, a lot of whatever. And we want to upload our documents in a vector database. And of course we need to do something so that this is working. We need to use the embeddings models to embed them in our vector database, and then the user can go on and ask something, and if it makes sense the user query will get sent to the vector database, so simply the LLM browses our documents and gives us the right answer. And now I want to show you why this is working. First I want to go in Paint. Let's just say these right here is the vector database. I make them simply as one big thing right here. Normally a vector database is 3-dimensional. I will show you this later. Then we have, of course, the embedding models. So here we have some kind of an LLM, and then we start, of course, with our PDF. So in our PDF is data, of course. Then our data will get sent to the embeddings models. The embeddings models makes these embeddings. These embeddings, they are just like tokens. These are basically numbers, for example, 0.2 or 1.2 or whatever. This embeddings model, they simply make vectors so that they make sense. And these vectors, they get stored in a three-dimensional space. Let's just assume that we have here one cluster of words that are, for example, between 0.2 and 0.4. And here we have, for example, a cluster of words that is between 1 and 2. And now I want to show you why all of this is important. So basically we use our PDF, and the embeddings models, they make these vectors out of these. So they make these numbers. And if you Google vector database, you also get a rough idea how this works. So this vector database is then, of course, three-dimensional. And you know, of course, we get these numbers out. And these numbers, they simply make sense out of these words. So for example, the word apple will be a similar word than banana. And these embeddings, they get these. And the other embeddings, for example, wolf, dog, cat, they have other embeddings. And this is really important to understand. So basically, things that have a value of 0.2, this could be, for example, right now a cat. And if we come right now and we make a query, we ask something to the LLM will browse this vector database and will search in the right thing. If I ask, for example, something about bananas, the LLM will simply search the vectors that are in the banana space. If I ask something about a monkey, the LLM will simply search in the vectors where he finds all these animals. It's really that simple. Also, here is a cool example. Basically, the content gets, of course, in the embeddings model. Then the embeddings model, they make these vectors. These vectors have different numbers and they make clusters. And then, of course, these clusters get stored in a vector database, and they get stored so that it makes sense for the LLM. And then if we ask, for example, a query, the LLM will go and search in the vector database in the right space what you want to get back. Let's just make an example right here once again. And now we do it completely different. Let's just assume that in this vector database there's a party. And at this party here is the bar. And here, for example, is the dance floor. And let's just assume that a lot of people come to this party. So on the bar there are, of course, the guys that drink all the time some beer. So here, of course, there are some guys and they have fun, they drink beer all night. So this is one cluster of embeddings. Then the second cluster on the dance floor, let's just say here are all the girls that have a little bit more fun than the guys that are just drunk. So here are, for example, the girls that have some fun. And where we are at this party, of course, we are not where the girls are, we are also not where the cool guys are. We are this cluster here, for example, and here are the AI nerds. So the AI nerds, they are here, they don't have fun, they watch a course. Makes sense, just like it should be. And now we assume that we are a dad or a mom from one of these girls. Of course, if we go into the party, we know immediately where we need to search her. We will most likely don't go to the drunk guys. We will definitely not go to the AI nerds, but we will go most likely to the dance floor, and me as a dad, I will spot my daughter immediately at the dance floor, because I know she is there. And that's basically how these embeddings in these vector databases work. The embeddings model, so this thing right here, let's just call it embeddings, this make clusters out of these words. Let's just say in this PDF there are some fruits, and then some animals, and so on. And these embeddings models, they will make these vectors. These vector embeddings, they get stored in the right place in the vector database. And as soon as we, as the user, ask a query, the LLM will know exactly where to search. Just like you as a dad or as a mom would search for your doctor at the dance floor and not where all the AI nerds are standing on this party. I think this should make sense. And this is why we can upload a lot of PDFs, because in the vector database there is a lot of space, and these embeddings, they are stored in one small portion, and if the LLM needs to search something, the LLM can search in the right spot. So if the LLM searches, for example, about bananas, it will search at the bananas embeddings, at the fruit embeddings. Just like we would search our drunk son right here at the bar, and if we have a doctor that likes to dance, we will search her most likely at the dance floor. Now let's just come back here one more time and add a little bit more information. Let's just say a user query starts right here, and a user query comes in, for example, to an LLM. If the LLM already knows the answer, it will already give the answer. So the answer comes back directly without searching the vector database. If we ask something where the vector database is not needed, the user query comes into the LLM and the LLM answers, and that's it. If on the other hand, the LLM does not know the answer, it will search a vector database. So let's just say here we have this vector database, and this vector database is of course trained with documents. So here are documents. These documents, they get first of all, of course, chunked into embeddings with the embeddings model, and then they are stored into this vector database. You already know how this works. If the user queries something that LLM does not know, it will simply searches this vector database and it will find most likely something out of this vector database. And then the results will come back once again. So basically it will bring documents here, and right now I want to show you something. It will bring a few documents. Let's just say for the purpose of this example, it will bring 4 different chunks back. This chunk will get feeded back into the LLM, and then the LLM answers, of course, correctly because the vector database got searched. In these chunks are always, of course, information from the vector database. And here we need to talk about chunking size and top K results. Now first of all, what are chunk sizes? Every single one of these chunks has a specific length. If we take our chunk size, for example, at 500, we will have 500 tokens, so small chunks, with 500 tokens in these files that come back. If we go with the chunk size of 5000, for example, every single chunk here has, for example, 5000 tokens. And here we simply do a similarity search. If I ask, for example, about apples, it will search in the vector database the sentences that are closely structured to mine, and then it will bring back the most relevant documents for me. And every single document has, for example, 500 tokens, because the chunk size is 500 tokens. And here you see we have 4 documents, and these results, they are called top K results. This is just a high-level explanation. You need to understand this, because later we will come back to these. The length of these documents is not fixed. Here we have different chunking strategies, and the results are also not fixed, because the top K, we can do it, for example, at 2, and then we only get 2 documents back. If we go up to 4, we get 4 documents back. If we go up to 8, we get 8 documents back into the LLM, and then we get the answer. This thing is right now just a little bit more information. Don't be confused. We will get to this, of course, in more detail later as soon as this is needed. For right now, you just need to understand that the user query comes into the LLM. If the LLM knows it, it will answer. If the LLM, on the other hand, does not know it, it will search the vector database. And in the vector database are, of course, the embeddings, because here we have inserted our document. It will do a similarity search, and it will bring back the top K results. And it depends on how high your top K is. If you go up to 8, for example, it will bring 8 documents. If you go down to 2, it will simply bring 2 documents. And the chunking size is also not fixed, but we talk about this stuff as soon as we start to develop these things ourselves. All these top K results, they come back into the LLM, and then the LLM will structure one last time sentences that make sense and bring the answer back to the user. And that's basically how all of this works at a high level. You know, to be honest, a lot of details, you know everything about the RAG technology right now, and don't be confused, we will come back into these chunkings later. We will come back into this top K stuff later. For right now, you simply need to understand that the LLM searches the vector database if it's needed. So in this video you have learned, I think, a lot of things. You have learned what a vector database is, you have also learned what embeddings models are, and you have learned why the RAG technology is working. Generally speaking, we can upload some text. It could be a PDF, it could be a CSV, it could be whatever. Then the embeddings model will come and it will make tokens out of our PDF. These tokens, they will get stored as vector embeddings in our vector database. The vector database is three-dimensional and there's a lot of space. And we will make clusters with these tokens. So there's, for example, a clusters with fruits, a clusters with animals, a clusters, for example, with prices. If we have some prices, there are different clusters. And if we ask the LLM something, the LLM can then go search this vector database, search in the right spot, and will find the prices where the prices are, the fruits where the fruits are, and the animals where the animals are. Just like you as a dad or as a mom would search your drunk son at the bar, and if you have a doctor that likes to dance, you will search her at the dance floor. That's basically how all of this is working, and this is why this works so cool. So we have nothing in our context window. The LLM will simply search the vector database and gives us the right answer back. This is how we can give LLMs additional knowledge. This is the best and easiest way to give additional knowledge. Yes, we can do fine-tuning, but the RAG technology is much more efficient and is much faster. And I think you should understand this really clear. So we can come back one last time at this graphic. All of this can work with LangChain, but it can also work with different frameworks. You will learn a lot of them. Basically, we can upload our stuff. The embeddings models store it in the vector database, and then we can use a user query. The LLM can do this so-called function calling and can simply query or search the vector database if it's needed. If it's not needed, the LLM will simply give us the answer back. So if we ask something that is not stored in the vector database, the LLM will not do function calling. So this is function calling with the RAG technology, and you have also learned what vector databases and embeddings models are. And I see you, of course, in the next video. In the next video we will install anything LLM and we will build basically our first RAG application. But before we do this, I want to show you how we can make RAG more efficient. How we can use vector databases in a way so that they get better. The first tip is, of course, to not store unnecessary data. So don't upload stuff in this vector database that you don't need. Insert only relevant information and avoid unimportant or redundant data. Then the second thing is, you should use either Q&A or Markdown as the optimal format. You can use question-answer pairs. This is really cool, so it makes searching easier. You should store directly retrievable compact information, and you can also convert bad data into Markdown. What do I mean by bad data? Let's just take a look at this Doggo PDF once again, because I do think this is a great example. This would be bad data, because here we do have like some pictures included, and pictures are not great in a RAG application. Basically we cannot find them. And if you scroll down, like there's a lot of junk included. We don't need these pictures. Sometimes we have some tables. The tables are not in a perfect structure, so we have here some messy data included. I do think this is a small PDF. This would be also fine, without making it like into special formats, but it will work a lot better. Also here you see a picture that will not work. So basically we should prepare this data and make it better. And here we have a lot of options, and the best option is to prepare this data into Markdown. Now how can we do this? It depends on the data format that you have. If you have HTML, you can use a HTML to Markdown converter. So if you are already on a web page, you can throw this HTML right in here and you get Markdown as output back. Then the second way is, of course, the llama parse. Llama parse is really great in order to create markdown out of messy data. You can run this either completely local with this code, but the easiest way is to come on Llama Cloud, and here you can come on parse. And what you can do here is you can simply upload everything that you want, for example a PDF, and then you can make this into markdown. Here on the left side you get all the settings. For 99% of the use cases you can use the standard default settings. This also works completely for free. You have a lot of credits, and what you can do is to simply upload your PDF. So you can simply drag and drop it in here, then this thing will get parsed and translated into markdown. If I press parse right here, first of all we need to upload this, and then of course we will get back our markdown, and this is also relatively fast. Let's just wait a minute until we get our answers back. And boom, here we have everything perfectly formatted into markdown. Here you can see the full markdown into display, but if you download this right here and you open this, for example, in a markdown editor, let's just open this up, it actually looks something like this. So you see perfectly structured markdown. No pictures are included and everything is structured perfectly readable for an LLM. Now these are informations that you can insert, and the retrieval will work a lot better. If you already have some small PDFs, easy structured PDFs, you can also upload just the PDFs. A lot of applications also do this automatically for you, so you don't have to do this always. This is more like if you have problems, go for it, and if not, you can also do it without the transformation into markdown. So test it out. If the retrieval is good, everything is fine, and if you have problems, make it into markdown. So keep this in mind. Use markdown or Q&A if possible. Just test it first without translating it into markdown, and if it doesn't work, you can absolutely go to the step. Then you can also summarize long text. So you can basically extract essentials and use shorter chunks for higher hit rate. This is also not always needed. If you have gigantic amount of text, you can eventually make summaries. Here you can also use LLMs in order to do this. But normally, like, the retrieval quality is really good also if you upload like entire books. Then the next thing is of course to use the right chunk size and overlap. But you need to always balance depth of detail with efficiency. If your chunks are too small, you will miss context. If the chunks are too large, you get poorer retrieval quality. You can also use special chunking strategies like contextual retrieval. We will talk about these strategies also later. Don't worry about it too much right now. You have also the possibility to use special RAG strategies. And lastly, as soon as your bot is created, you need to test your bot. So check whether it delivers the desired answers or not. If necessary, adjust the chunking or overall structure. These are the things that you need to think of. The most important things are that you don't store unnecessary data in your RAG application, and keep in mind that you can make markdown out of messy files. And I see you of course in the next video, because in the next video we will actually start to create a local RAG application with Anything LLM. In this video we will install Anything LLM locally on our own machine. With Anything LLM we can build RAG applications. You can also build somehow like AI agents, and the coolest part is you can do anything locally and we can connect it with Ollama. Before we do that, I want to tell you that we have also software like LM Studio. Also LM Studio has some advantages, for example with the model context protocol and GPU offload. We will talk about LM Studio at the end of this section. But now let's just come back to Anything LLM. You can simply Google Anything LLM, you press on the first link, and then you press download for desktop. You search of course your right operating system. For me it's of course once again Windows. I have already installed this, but I will do this again because I think that this thing got an update, so I want to make this update with you. And Anything LLM ships updates all the time. If I come to downloads, you see Anything LLM desktop exe. We can open it up, then double click on it. We need to verify it. Then this thing will pop up, it's only for me, and I install it on my local machine. Sooner or later this thing will tell you that it needs to install some required packages from Ollama, and of course we need to accept it. Now everything is installed and this thing will load up. Then we are in this interface, and this interface is relatively easy to use. I would guess as soon as you have installed this, that you do not have these chats because these are older chats that I already have. I want to show you briefly the interface so that you can understand what we can do here. First, of course, you can create new workspaces. This right here is already done by me because I have already a lot of workspaces. But of course, you can do this yourself. If you come on the left corner, you see that you can hide the sidebar and you can open the sidebar just like in ChatGPT. You can add a new workspace by pressing on plus and you can give this a name. Let's just say course test. And then you can simply save this up. Then you are in this new workspace right here, and here you can type in stuff, but this thing will only answer as soon as you have included your model. You can send your prompts here. You can also speak your prompts. You can change the text size. You can view all available agents. You can view the slash commands for chatting. And of course you can upload stuff here. So really simple, this is basically just like in ChatGPT. If you come on the left side, you can switch between your workspaces. And you see that I have a lot of workspaces running right here. And in your workspace you can also use new threads. So you see, I have right now 3 threads in this course test. But before you can do this, you need to make most likely a few settings. If you press in the left corner, you can support anything LLM developers. Of course, you can also read the whole documentation by pressing on this thing right here. And something like this will open up. It was in a new browser for me. And here is the whole documentation if you need more help. The next thing is that they also have a Discord server so you can chat with them. And of course here are the settings, and the settings are most likely the most important stuff, so we can press on the settings. If you are on the settings, we start right here with our providers. You can press on LLM and here you can use the provider that you want to use. If you press on these, you see that you can use the OpenAI models, Azure models, Anthropic, Gemini, NVIDIA NIMs, Hugging Face, you find LM Studio, Mistral, Perplexity, OpenRouter, Grok and a lot more, but what we want to use is of course right now at least Ollama, because we have already installed it. The next thing is that you can use a model. And the Ollama model that I want to use right now is Llama 3.2 in the FP16 format. The max tokens, just leave them at the default, at least for right now. And then you have the Ollama base URL. This is important. If you open up your terminal and if you type in Ollama surf, this has to be the same number that you see right here. So HTTP and then exactly this number from here. If you do not use the same number, it will not work. The performance mode, just leave it at default. And the Ollama keep alive, you can leave it just as 5 minutes, this works. We don't want to use any token, but this is of course on you. And then as soon as this is done, you can simply press save changes. And then you are connected with your Ollama with the model that you have specified here. The next thing, the vector database. We can use different vector databases. I would suggest for right now that we use LandsDB. This works 100% locally and this is automatically included in anything LLM. If you use stuff like Pinecone for example, you can totally do this, but here we have to work with API keys and an index and we do not want to do this right now. We will do this later in Flowwise and NIDN, so we make it simple, we use LandsDB because this is already included and we press save changes. Then the embedder. You can use different embeddings models here. You can use the models from OpenAI if you really want to. And here I would suggest that you use, for example, the OpenAI free small embeddings, but also here you have to work with API keys and we do not want to do this, at least not right now. So we use the Anything LLM embedder and this works completely for free, locally on your machine, so save changes. We do it as easy as possible. Then the text splitter and chunking. You already know how important this is. For the sake of this tutorial, we leave the text chunk size at 1000 and the text chunk overlap at 20. In the next video I will go into more detail how we can work with chunk size and the overlap in order to get the most out of our RAG application. Here you are also a little bit limited with a length of 1000. Later in other applications we can do this a little bit better. Then the voice and speech. You can use local whisper, this works for free. So I would suggest that you leave this as it is. And if you want to use text-to-speech preference, You can also use stuff from OpenAI. This works a little bit better, but here you also have to work with an API key and so on. I have already done this a few times, but for you, just use the native system and press save changes because this works for free. Then the transcription, also here you have a built-in tool, but you can also use Whisper from OpenAI if you want, but we leave it as it is, as you know. Then the admin, you have general settings, and if you press on these, you can enable network discovery if you want, and you can use a community hub access level. We don't want to do this, and you also have workspace chats, and you can share these chats, delete these chats, do whatever you want, and you can also export them. Then you have these agent skills, and if you press on these agent skills, you see that you have rack and long-term memory, view and summarize documents, scrape websites, generate and save files to browser, generate charts, web search, SQL connector, and I would suggest you strongly that we leave all of this add-on. I want to show you over the next videos what these things can do, and of course as soon as we build this rack application you need to have this add-on, so make sure that you include everything here, just toggle them add-on. We also have custom skills, agent flows and MCP servers. I am personally not the greatest fan of agent flows and MCP servers inside of anything LLM. We will work with MCP servers a tiny bit later. This is for right now a bit too complex. Don't worry, we will get in all of this, but we do not do this with anything LLM. We use other software because I think it works better in other software. So just leave it on. I want to show you a brief overview of these things later. But for right now, forget it and press save. Then we have the community hub. You can go on customization if you want. The theme is of course default because we do not want to have this at light. The display language, just use whatever you want. I use English for this course. Message chat alignment if you want. Show chat window scroll bar. And you can also customize the automatic message displayed on your users if you really want to. And here you can also use a system message. We will talk about system prompts in one of the next videos in more detail, because in the Ollama app we had not the possibility to set a system prompt, at least not in an easy way. System prompts are important. Yes, they are even important in software like anything LLM, and they will get especially important as soon as we build AI agents with, for example, NLN or Flowwise. But keep in mind, the system prompts, they will get important over the course. Then the tools, of course you have the event logs. These are simply some vector databases that I have included here. The developer API, we don't need this. The system prompt variables, so we can add different variables, for example, date and time and so on, so that anything LLM always understands what date and time is. And lastly, the browser extensions, and I also don't use the browser extensions. And also here you can contact the support and you can read everything about privacy and data. But because everything works here privately, of course we have no problems. Right now everything is set, so you can come back to anything LLM and you are once again back here in this interface. And here you see that we have created a workspace. We did everything in the settings. Then we can send a chat, embed documents, set up system prompts, define a slash command or visit the community hub. And the quick links are also here. Send chat, embed documents, create workspace. Custom agents, we will talk about this a little bit later. The slash commands and the system prompt. You can press on modify a system prompt and then you type in exactly here what you want to have. It's really that easy. You can simply tell this thing, you are a helpful assistant for XYZ, look in your vector database for XYZ and so on. This is just your private ChatGPT. I just leave this at default for right now. And you can also see that you can work with variables if you want to include time, date and so on. So they are really helpful with everything that you can do. And you can also see that you can have a chat history, for example 20 messages, so that this thing remembers for 20 messages what you are talking about. And here you also find these things once again. The general settings, the chat settings are this thing right here. The vector database that we want to take a closer look in the next videos, and the agent configurations. So once again back into anything LLM, Here are the updates and the announcements. Of course, we have MCPs, NVIDIA NIM support, and so on. Here will come new stuff as soon as you see this, of course. And right now we want to send a chat. So we are, of course, in a workspace, and if I type in right now, hey, hopefully Llama will talk back, and yes, it does. How can I assist you today? This is our local Llama model that talks back to me in the interface of anything LLM, and in the next video we will start to build out our own RAG application. We have made all the settings in this video. We did it like a little bit faster, and I see you, of course, in the next video. As soon as we start to build RAG application in anything LLM, and of course we need to dive a little bit deeper into chunking. We have created a workspace. We made all the settings down here, and we send it our first sentences in the chat, and Ollama talks back to us. The next thing that we should do is to embed the document. I have already done this, but in your case you will simply press on these and you will land in this interface. And here we can upload stuff. But before we upload stuff, I want to talk once again briefly about chunk size and overlap. If you come back into the settings once again, and here text splitter and chunking, you see that you always have the text chunk size and the text overlap. So let's just dive a little bit deeper. First of all, here we have one limitation that we can only go up until 1000 tokens per chunk size. Later in other models we can go a lot higher with these. And of course, if we work with Ollama, we have also the privilege that these models are free. So let's just talk about a view of the basics here, so that you understand how you should set your chunk size and the chunk overlap. First, I want to tell you a quick problem with these RAG applications. I want to show you something. So we go here, of course, in Paint, and let's just say your document looks something like this. Let's just say that you have a PDF or a markdown text or whatever. Your markdown text will look something like this, so let's just say there are a few pages of text. Generally speaking, if we upload the entire PDF in our vector database, the LLM always sees the first part of a PDF relatively clear and also the second part of the PDF relatively clear, but the stuff in the middle, yeah, this stuff is not that great. So the LLM will not be that accurate with this stuff in the middle. But we have something that is called chunk size. We can feed the LLM small chunks, and then these chunks get embedded. If we embed the whole document at once, it is a high probability that the stuff from the middle ground is not perfectly accurate. But we have, of course, the chance to make chunks of this text. For example, a chunk could be something like this, then this, then this, and that. So we have, for example, 4 chunks, and every single chunk right now is separately embedded in this vector database, and then the LLM can always search these chunks. This is an important concept that we need to understand. And the next important concept is that we can not only make these chunks, we can also make chunk overlap. Let's, for example, say that we have 1000 tokens right now in this chunk. So the LLM will search, for example, for dogs, and let's just say the LLM find a lot of dog chunks or a lot of dog tokens in this first chunk. And maybe also something down here. So the LLM can be a lot more efficient and only searches this first chunk and this third chunk and will not take a look at this chunk. If we don't split these, if we don't make these splits, the LLM will search the entire PDF and the output will not be that great. The output will most likely miss a few chunks from here. But of course we can make these chunks, and then the second thing is that we can make chunk overlaps. An overlap simply means that we can also take this right here. So the first chunk would be, for example, this entire chunk until down here, but as soon as the LLM searches the second chunk, it will also search in this middle ground once again. So if there are some tokens about dogs right between these two chunks, the LLM can search these chunks a little bit more accurate. You know, every LLM has a token limit, and if the token limit is a little bit too small for our chunks, for example for the whole PDF, the output will be really bad. Yes, the token limit gets bigger and bigger and bigger with better and better models, but still chunking down these PDFs is important. And I want to give you some rules. If we go in a text, this would mean something like this. If I upload this whole text without chunking it down, the LLM will see most likely relatively clear what's in the last part of this text and also what's in the first part of this text. But if we chunk it down, for example, in 5, 6, 7 chunks, the LLM will always search one chunk, for example, until here, and then searches the second chunk, and the LLM can give us the most optimal tokens. And if we use chunk overlap, the LLM will also take a closer look twice at these chunks that are overlapping. This is an important concept that you need to understand. I want to give you some general rules. If we zoom in this text a little bit that I have written right now, it depends on the type. So of course it depends on what type you use. For example, if you have stories, you can use chunk sizes between 1000 and 5000 if the context window of the LLM is large enough. If you have a big model with 8000 tokens context window or 250,000 token context window, 1000 to 5000 tokens as chunk size is completely fine. If on the other hand you have shorter texts, shorter stories, shorter PDFs, between 500 and 1000 is perfect. If you have on the other hand items with lists and links, 100 to 500 could be a little bit better. And then the chunk overlap, roughly 1 to 5% is perfect. This means if you have a chunk size of 1000 token, an overlap between 10 and 50 is perfect. And generally speaking, you should play a little bit with these. Just play a little bit with these as soon as you make your rec applications, because we cannot say like this text you need 2500 and an overlap of just 20. You need to play a little bit. Every text is unique and you need to play a little bit. But generally speaking, lists, shorter chunk size, short stories, a little bit bigger chunk size, really long stories and books, here you can use really large chunk sizes. So 1000 is a perfect mix between stories and shorter texts, but maybe it's not optimal if you have items with lists and links. If you use items with lists and links, just go a little bit down. Generally speaking, you always have just a word and then the price, and for that reason the chunk size should be small, so that the LLM looks at this small chunk and find your price with this item immediately. So of course the chunk size should be small and also the overlap is not really that important. And a quick other note, if you have like normal lists, for example an Excel sheet or something similar, normally we should also use SQL and not rec for these applications. This is just if you have like some text and also a little bit of lists are included. Of course, more on SQL later, because we will use SQL in NA10. And that's basically every single thing that you need to know about chunk size and chunk overlap. This is the next big thing that you need to know if you want to make a perfect rec application. So I think now you are perfectly ready to rock with your rec application. In this video you have learned that you should use the chunk size and chunk overlap correctly. Long stories, long chunk size. Short stories, shorter chunk size. Lists with prices or something like that, really small chunk size. The overlap, use something between 1 to 5% of the chunk size and you are ready to rock. In this video we will build a rec application and we do it once again with this example because I think this is a nice PDF. Generally speaking, you know that you should convert this PDF into Markdown. But for the sake of this tutorial, we do it easy, we do it fast. So you know these pictures will not get embedded, but like I told you, I just want to do it quick and fast. The first thing that you need to do is of course to use the right text chunk size and the right overlap. Now think for yourself what you should use on this PDF. This PDF is not too big, but also not too small. We have some numbers, but we have also sentences. So I would guess we should use, for example, a chunk size of, let's just say, roughly 800. And the overlap, we can use 20. We have some numbers. I think this is completely fine. And remember, in anything LLM, we cannot go over 1000. In other LLMs, we can do this. If you go too high with this thing, your rec application will also slow down dramatically because you need to process more token on every single generation Yes, of course, it's for free over Olama, so let's just save here 800 as chunk size and 20 as overlap, save changes. Now we come back to anything LLM, and now we can press embed the document. And now you can embed every single document that you want. Right now for this example, we can simply use this PDF, and I have already uploaded this PDF. But you have also the possibility to upload other stuff. You see it here. You can upload CSV files, spreadsheets, even audio files and a lot more. And you can also fetch entire websites. So yes, you can also do scraping here. Every single thing is here included. You can simply copy your link here, or you can throw in your stuff here. But I have to tell you, in my experience, it works better if you convert it previously in Markdown and do this manually yourself. Yes, it will work, but it will work most likely a little bit better if you convert it first into Markdown, because they mess a little bit up, at least sometimes in my experience. Normally this should work in the background here, but like I told you, it works better if you do it manually. You have also data connectors, and with these data connectors it's really cool because you can also use a GitHub repo. If you press on GitHub repo, you can give the URL to the GitHub repo, eventually also an access token, then the branch will leave it on main and the file ignores. But I also have to tell you that GitHub does not like to be scraped, so please a little bit cautious with GitHub. You can also do the same thing with GitLab repos. You can do the same thing with YouTube transcripts. You can simply give the URL and this thing will make a transcript for you completely automatically. Also here in my humble experience, it works better if you do it manually first and then upload the text file. You can also use the bulk link scraper, so you can give a few links from websites here. You can also use the crawl depth and the maximum pages. So you can also try to scrape web pages here, and you can also include Confluence. It's really that easy. Just give your links and try it. Just give it a shot. Maybe it's accurate enough for you. What I want to do it fast is we come on documents, because we will not do every single one of these. You can try this yourself. We can simply come to documents. As soon as you have a document included, you need to move it into the workspace. And in order to do that, you simply press on this thing here, and then you can press move to workspace. And if you have more than just one document, of course you can use 2 documents, you can use 3 documents, whatever. And as soon as you press move to documents, it will come in this right corner, and then you can press save and embed, and then this thing is embedded. And as soon as this thing is embedded, you can talk to it. It works really that easy. And as soon as this thing is embedded, you can also press here to pin it to workspace. So if you press on it, right now it's pinned. When you pin a document in anything LLM, we will inject the entire content in the document into your prompt window for your LLM to fully comprehend. This works best with large context models or small files and so on. So you see everything is right now, of course, in your workspace. If you close this down, right now this thing is pinned. And if you press here, you see that you can also insert documents, because right now this thing is not inserted in your specific workspace here. So if you want to have this in your course test, just press on it. Also here, move to workspace, save and embed. And right now this thing is also embedded, of course, in your course test. And as soon as you press on this course test and you are, for example, in a new thread, you can ask questions about these documents. So for example, what is COD? Let's just say search documents. Based on the provided context, COD likely stands for chain of draft prompting technique, a quick research and so on. So basically you see our LLM does function calling and it exactly knows that we talk about chain of draft. Now let's just do a quick test. Let's just see this DeepSeek R1 stuff. If I press here on Observed, you see that I have not observed any document. And if I press on these, and if I ask, for example, what is COD? Search documents. By the way, you don't have to type in search documents. I just want to make it clear. You see this thing does not know what COD is. COD could be, for example, any type of fish or whatever, something in the DNA. You see, COD is a new concept. Llama is not trained on it. This only works because the RAG technology works here in the background. And if you want to insert your document also here, you can do it really easy. You simply press new thread. As soon as you are in a new thread, you can either press here upload, or you can also press here upload the document. And if you press on it, you are once again here. You can simply insert your documents here. Let's just use this Doggo PDF for this example. I move it into Workspace, Save and Embed. And right now we can ask questions about chain of draft and also about this Doggo PDF. If you do not like to have specific stuff here in it, you can simply press back and then this thing is gone. And right now we can only ask once again about the chain of draft document. So let's just close this down. You see that we have these documents also here included. Let's just delete them because I just want to use the vector database and I can ask also something specific about this chain of draft. Let's just ask once again something about latency with chain of draft. A generic question. What is about latency in chain of draft, for example? If I send this out, you see that we search once again, of course, also the document, and I want to show you something really cool. You can also see the chunks that we have searched. So show citations. It is, of course, from the chain of draft PDF. And here you can see that we had a reference of 4 times, and you can basically see the 4 chunks that we have. So first chunk, second chunk, third chunk, and the 4th chunk. So these are the chunks. And you see also this right here. We have these 4 top K results, and this chunk matches 40% with our question. So they do a similarity search. This chunk matches 42% with our question. This chunk matches 43%, and the first chunk matches 51% with our query. So the similarity search gives us 4 top K results. The first one has a semantic similarity source of over 50%, and that's why we have this thing right here. And you see, but what about latency? This is exactly, of course, the phrase that is right here. So we basically have this chunk. We have 800 tokens here. And we can simply see for ourselves how all of this is working out. So this is basically the easiest way how you can build a RAG application on your own local machine. And it's really easy in anything LLM. Just use the right chunk size with the right chunk overlap. Upsert your PDF. It's really that easy. I want to show it once again. It does not matter in what workspace you are, just simply press here on Upsert, and then you can simply drag and drop it either here or come to data connectors. Then you move it into your workspace by pressing here and press Save and Embed, and then this thing is embedded in the workspace where you are typing. If you come in anything LLM and press embed a document here, you can also eventually pin it to feed or unpin it to feed if you want. That's basically everything that you need to know, but remember, it will work better if you make this into Markdown yourself. And we do not rely on the stuff that works in the background of anything LLM. Sometimes it can work, but it does not have to work that great. But right now you can build every single RAG application locally on your machine as easy as possible in anything LLM with a great interface, completely for free. This video will be a quick one. We talk about system prompts, the top K results, the memory of your RAG application, so not the vector database. We talk about temperature from the LLM and also the similarity search results. The next thing in anything LLM is, of course, this thing down here. You see, set up a system prompt. You can simply press on it once again and you will be in these settings once again. And on this chat settings, you can simply scroll down. The chat mode is, of course, chat and not query. The chat history, I have already told you this. This is the stuff that anything LLM knows your context, so it will remember what you are talking about. If you come down here to 1, for example, and you say in one of your workspaces, my name is Arnie, and then you talk a little bit and you ask once again, what's my name? It will not remember. But if you go up to 20, it will remember this for 20 messages. This is important. Just leave it at 20 because 20 is recommended, but you can also go up to 45. But yeah, then you will get some failures. They use a Windows buffer memory for these. Then we have the prompt, and of course here you can type in your system prompt exactly as you like. The default system prompt is, given the following conversation, relevant context and follow-up questions, reply with an answer to the current question the user is asking. Return only your response to the question given the above information following the user's instructions as needed. So basically this thing is already tailored for a RAG application. You can simply leave it as it is, But of course, if you want to do something specific, maybe you use this tool only for accounting or for whatever, where your data needs to be private, please just set up a system prompt. And if we talk about system prompts, I like to do it somehow like this. We always start with a role. So what is the agent's task? Then we should give it a goal. What should be achieved? What are the tools that are included? If we work with anything LLM, most likely you only have the internet access or maybe also the rec application, so the vector database. You can give some rules, so how it should behave. Then the style, so what should be the tone, the language or the formatting rules. You can also specify the output format. This is like, yeah, somehow special. This works later in NLN and Flowwise better, but you can also try it in anything LLM. You can also give examples with the shot prompting that you already understand, and you can also set some variables, for example for date, time and the username. You already saw in one of the previous videos that you can easily include this with JavaScript variables. An example prompt in Markdown would be something like this. You can simply read this yourself. This is for a business analyst. You need to make the system prompt that works perfect for you. Generally speaking, I don't like to play like that much with system prompts in anything LLM. It works a lot better with AI agents if we build them with NLN, but you can give this a shot. Especially the parts and the tools, this is not really necessary in anything LLM. But you should eventually give a role, you should also give a goal, and you should give it some rules. You already learned this in the basic prompt engineering guide from Anthropic. And this in the system prompt, it simply makes the whole interface from anything LLM behave how you want to. Also on the style, you can specify the language in English, for example, or if you want to have other languages, simply use them. You can include different lengths so that the LLM answers a bit shorter or something like this. And eventually, yeah, the Markdown output doesn't work that great in anything LLM. This is a basic structure. You can play with this. Not everything will work in anything LLM immediately, but most of this. If you work with the standard prompt, you're perfectly fine for a rec application. And if you want to include date, time, or something similar, you can absolutely work with these JavaScript variables. I would recommend you to give the standard prompt a shot and also include some examples if you want to give them, a style if you want to have a specific style, and some rules that are perfect for you. You don't have to include tools, because this is more for later as soon as we start to build AI agents. And then we have the query mode refusal responses. If you do not want to have answers on specific questions, you can type it in. And then you have something else also here, the LLM temperature. The temperature simply means how creative your LLM responses will be. So it simply means if you go up, for example, until 1 is like the maximum that I like to use. I don't like stuff that goes way beyond 1. If you use 1, for example, this is the default settings into ChatGPT, your LLM will be a lot more creative. It is better for creative writing, articles and so on. If you want to do accounting, I would suggest you to go down like between 0 and 0.3, 0.4. But here the answers will be a little bit more redundant. It doesn't sound that right, let's call it this way. If you come back up to 0.7, 0.8, you are on a good middle ground. It depends, of course, on what you want to do. So this is basically everything that you need to know about your system prompt. And then you can simply press Update Workspace and you are done. The same thing is also here true for the vector database. Here you can type in, of course, the search preference. I just like to leave it as default. Then the maximum context snippets, you already know it, these are the top K results. They recommend you a top K of 4, but in my experience you can also go up until 8. Anything LLM works here relatively good with these top K results, but like they tell us, leave it at 4, so we can also do this. And then a low similarity score if you have, for example, something that is below 25%. So if the similarity search is below 25%, it will not trigger. I would also leave this at the default settings, because if you do this with no restrictions whatsoever, you will get every single time results, and if you go up until 75 you will like mostly never get results. It also depends on what you search. For accounting you can go eventually up until 0.75, because then you will get only the most relevant documents. But if you want to do a normal similarity search, for example, on texts that are a little bit more generic, just leave it at 0.25. And that's basically everything about the vector database. The general settings, you already know this. And lastly, the agent configurations. Here you only have the agent skills, and the agent skills right now are all add-on. And the agent skills is also the stuff that we want to talk in the next video. So in this video you have learned that you can set a system prompt, you can set your top K results, you can set your temperature, and you can also give the similarity search. You can play with these percentages a little bit. And of course you can also give the context how long anything LLM should remember your previous conversation. In this video we talk about the agent skills from anything LLM, and we do it relatively quick because I tend to not like this that much. I have to be a little bit disappointed here at least sometimes. Now what works great is of course rec and long-term memory. If you press on it and throw it on, you already know it, this is the stuff that we already done. And you press save, this should be active all the time. The next thing is view and summarize documents. And here you see allow the agent to list and summarize the content of workspace file currently embedded. By default this skill is enabled and so on, so you can basically summarize the whole documents and not only do the similarity search. So I would suggest you to leave this add-on because it works somehow good in anything LLM. Then scrape websites. I also like to leave this add-on always. And of course I show you how all of this looks in the interface. Then generate and save file to browser. I personally turn this off most of the time because this seems to bug from time to time. Generate charts and the web search. On the web search you can also use different things to browse the web. You can use for example the Google search engine, but here you need to type in an API key. 100 queries per day are for free and then you need to pay. If you want to have it every time for free, just use DuckDuckGo and is also for free. So let's just see how these things are working. If you come to anything LLM, let's just say in this workspace, and we use a new thread. You see these things down here. The first thing that you can do is of course add files. Let's just say this chain of draft, and also here you can ask make a summary. Because we have this agent skill here included. So here you see chain of draft and so on, and now we get the summary. The next thing are the slash commands. We need to accept them later, so let's just talk about these agent skills now. If you press on these agent skills, you see that you have a lot of different agents. And first I want to show you how we cannot use them. Let's just ask something where we need most likely internet access. Who is the current president of the USA? Normally it should be, of course, Donald Trump, but this thing tells me I don't have real-time information and access and so on, so basically it does not know. But if you press on agent, you can press on add agent, and now we will ask an agent. And if I ask the same thing right now, so who is the current president of the USA, and I send this out, we will use the search engine. You see, agent get invoked. And right now you see that we have Donald Trump as the answer, but I have to tell you, I needed to try this a few times, so the web search and the agent skills are not that great in anything LLM. The same thing is true for generating charts. You can try this out. Let's just try this. Make a pie chart of this 50% Bitcoin and 50% stocks, and we send it out. Let's just see if the agent can do this. Now first, I have forgot of course to invoke the agent. So this is of course not correct. This is the normal answer, but if we type in add agent and ask this again, we should at least in theory get a chart back. Let's just send it out and see if it works or not. So you see the agent is working and the pie chart is still a little bit of a mess. That's why I do not really love these agent skills. The next thing that I want to show you is a quick tip. Define slash commands. If you press on them, this thing will open up. You can simply type in the command that you want. This is something like a shortcut. So your command would be, for example, LLM. And with this command you can trigger a prompt. And here you can type it in and you can also read it for yourself. This is the content that will be injected in front of your prompt. So every time as soon as you type in a prompt, but you use a command before the prompt, you can trigger this. This could be a longer prompt, a shorter prompt, whatever. Like for example, make sure to answer with just a few words. Use simple language, for example. And lastly, also description. Respond short. If you save this, and we are now here once again in a chat, you can simply see for yourself what you have. You have here either reset to clear all your chat history, you can use /LLM to respond short, and you can add new presets. So if you type in /LLM, you can simply ask whatever you want. What is a LLM? And right now, your prompt will get injected before your question. So the LLM will understand that it needs to answer shortly and precise. And it tells us large language models. So you see this was perfect. So this is really, really short. And of course you can add new. So if you add, for example, add new preset, let's just say your command would be right now long. Use descriptive language and explain concepts in details. And the description, let's just say long explanation. We save it. Then we can do this once again. Let's just say /long. What is a LLM? And right now I would guess that we get a longer description, a more technical description. And here you can see it immediately. /LLM, this is right now our short command, as you can see it here. LLM, respond short. What is an LLM? Large language model. And if we use /long, what is an LLM? We get a long descriptive answer back. And right now you see that we get everything back from the LLM. Understand context, generate text, translate language, answer questions. We have encode, decode, self-attention mechanism, virtual assistants, chatbots, language translation, content creation, bias and fairness, and so on. So you see we have like every point of view for an LLM, just because we use one of these shortcuts, so they can make prompting a lot easier, a lot simpler. You can add here chain of thought prompting or whatever you want, but simply press on add new preset, give it the command name, the prompt and the description so that you remember what this thing does. If we come back once again in anything LLM, of course, we can come back to these agent skills once again. So agent configurations and configure agent skills. Now we are here once again. On these agent skills, you can play with them just a tiny bit if you want, but what I like in anything LLM is the extremely simple rec application that works locally on your machine. The next thing that you can eventually play a tiny bit with is the agent flows. I have already created one agent flow. I have also played a little bit with these MCP servers. They are really a hype right now. But on MCP servers we need to do a deep dive later. And on these agent flows you can press on this agent builder. And here you get this interface. You can give it a flow name, then the description and the flow variables. And you can add more blocks if you want. You can add API calls. You can add LLM instructions and so on, and I also have to tell you that I do not really love this one. So long story short, on these agent skills, at least in theory, you can create pie charts. You can summarize documents. The summarizing of the documents works great. You can search the internet. This is a little wobbly. And most of the other agent skills and these agent builders, they are like really wobbly. And if we want to talk about MCP servers, of course we need to do this later. So all the exciting stuff about agents, we will do this in applications like n8n and Flowwise because they are a lot more reliable. This thing is of course perfect for a easy to build local rec application. And that's what I want to recommend. Use anything LLM to build simple local rec agent. If you want to do a little bit of accounting with private data on your local machine, this is perfect. But don't try to spend too much time with these agent skills because I think you will be disappointed. But nonetheless, let's just hope that they fix this. Let's just hope that these things come really reliable, and then I will update the course. And the last thing that I want to show you in this video is visit Community Hub. If you press on these, you are of course in a new browser and you will be in the Community Hub from anything LLM, and you can see for yourself if this is helpful or not. And as soon as you have done everything, your interface will change slightly. You see custom AI agent, /commands and the system prompts, and you can always press here right now. So as soon as you have done everything once, your interface will change slightly. See you in the next one. Until now we worked with Ollama, and Ollama is great. You can make endpoints and you can connect it to anything LLM, and later we will also connect it to a lot of automations. But some people want to have an all-in-one solution that is really easy, something where we don't have to make endpoints. And in this video I want to actually show you something that is really cool. You can use a software called LM Studio. With LM Studio you can run every single thing locally, you can download a lot of different models, and you have also some advantages over Ollama. The biggest advantage is that you can find and search these models directly inside of LM Studio. The second advantage is that you don't have to make an endpoint because you can do every single thing inside of LM Studio. And the third advantage is that we can use the Model Context Protocol really easy. We will not talk about the Model Context Protocol yet. We will do this later. So keep in mind, LM Studio is also a great software and you should absolutely take a look at this. It always depends on your personal preferences. LM Studio has also something that is called GPU offload, and we will also take a closer look at that. The first thing that you will do is, of course, to simply Google LM Studio. And the first link will be the right link. You can actually press on these, and here you get all the information. If you basically scroll down, you can read every single thing for yourself. They also have a CLI, an SDK, MCP clients and so on. Don't worry about this just yet. They also tell you everything about privacy, the terms of usage and so on. So if you want to build something for a company, also read these terms of usage. For right now we simply focus on the application, so you would simply download this for Windows or for whatever machine you have. After the software is downloaded, you can simply install it and then you will be in an interface that looks something like this. And I want to give you a brief overview so that you understand exactly how you can use this. Here on the left side, you can either hide these chats or you can include them. And on these chats you can basically chat, just like with anything LLM. And here you also have some options. But before you chat, of course, you need to make a few settings. On the left side, the next thing is here developer. And on developer you can basically make endpoints. If you press here on settings, this is basically the server point that you can access, so you can also make endpoints right here if you want to, and it's reachable exactly on this URL. It's similar to Ollama, but you don't have to make an endpoint. Besides this, you can also enable cores, and you can always come over these question marks and read for yourself what all of these options are doing. You can save on local network, you can do just-in-time model loading, auto-unload, for example at 60 minutes, and so on. For right now we will not need this developer console, but here you will find everything also for debugging and a lot more. Then the next thing is the models. These are the models that you have downloaded. Maybe you don't have any models yet. I will show you of course how you can download these models. If you come here on search, this is basically the tab where you can find these models and to download these models. Before we download these models, I want to give you still a little bit more overview. If you come on the left lower side, you see here LM Studio and this is the version. So if you press on these, you can copy the version and so on. These are just some links that you can follow if you want to have more information or documentation. Then you have here user, power user or developer. If you come on user, basically you will have a really simple interface. If you come on power user, this thing will get included. And if you come on developer, you also get some more settings. I would recommend you to leave this at developer because it's always nice to have enough settings. Then if we come to the right side actually, let's just start down here. Here you have some app settings. If you press on them, you get a lot of settings in overview. Here you have general. You can update your app because LM Studio makes updates all the time. You can also try to use the beta apps, but I would recommend you to leave this at stable. Then you have the general settings. I would recommend you to leave this at the standard settings. But most of this is just like how you want to have this looking. The color theme, I would strongly recommend you to leave it at dark. Or maybe you also like sepia, but I really hate it. So we leave it at dark. Then the language, we leave it at English. Then the model defaults. These are just the default settings. You can change this later. I would also recommend you to leave this at this 4000 tokens because it works really fast with this. The model loading guardrails, we leave them as strict. And also everything else down here, we leave this as it is. Then if you come on chat, you can also take a look, for example, at shortcuts expanded reasoning, and so on. You should always click yourself through all of this. Maybe you find something that you really want to include. Then you can come to developer, you can show the debug info block in the chat. You can enable model load configuration support, and you can also separate the reasoning content if you want. And lastly, you have here these integrations. For right now, I have the model context protocol included with NLN and Supabase. We will take a closer look at this later. Don't be overwhelmed. This will be easier than you think. Then you have here the model search, where you can search your models. You have the runtime. On this runtime, you find basically a lot of different settings. You see that I have a Windows machine and also CUDA is included. And we can also make eventually some updates. And if you come on hardware, you see basically your hardware. I would also recommend you to leave the settings how LM Studio sets this up for you. Because LM Studio is really great to enable everything really smoothly for you. I do think that in LM Studio you can run these models a tiny bit faster than in Ollama. And down here you have also sharing if you want to. Let's just close this also down for a brief moment. Then down here you have account. This is basically the same setup here. And if we come up here, you see that you can come on this sidebar here and the sidebar will pop up or close down. If we come on the left side, you see here context. This is an unsaved preset with a system prompt. And here is a German system prompt for me. So this is the place where you can set your system prompt. Remember, you type in, for example, you are a helpful assistant for XYZ and so on. You give a role and so on. You understand system prompts for right now. And you can also save the settings or create new ones. Besides the system prompt, you have also the possibility to come to models. And on models, you can change the temperature. The default settings are at 0.8, but you can come up and down, just like in anything LLM. You can limit the response rate if you want. You can increase or decrease the token count here. If you want to have always really short answers, you can come down or up, just like you want to have it. Then you have the top K samplings, the repeat penalty, the min P sampling, and the top P sampling. Normally also the standard settings work here really great, but you can play with the settings a tiny bit. Don't go up or down more than 5% from the standard settings. Then you have structured output. If you want to, you can include this, and you can use, for example, a JSON scheme if you want to have always JSON as the output format. And then there's speculative decoding. I would not recommend you to use this. And lastly, you have here program, and on program you can include a CS code sandbox, you can include the RAG, and you can also include the model context protocol, but like I told you, we will include the model context protocol later. If you come here on these integrations, you can press on it, and here you can basically edit a config file, and with this config file we can basically include the model context protocol server later. Like I told you, please don't worry about MCP yet, we need to do this later, so that it stays easy for right now. The last setting that I want to show you is this right here. You can press on appearance, and here you can also change the style a tiny bit from this application. For right now, this is everything that you need to know. The next thing that you will do is of course to download the model. In order to do that, you press here on Discover, and you can search the model that you like. You can simply scroll through these models. Here are always the newest models that a lot of people are using. And you see here what's included. This right here is vision. This model can process image inputs. These here are tools. So let's just see, this model has been trained for tool use. So also tool use and function calling is included. And this here is the test time compute. So this model supports reasoning. This model is called Magistral Small. This comes from Mistral. So if you press on these, you can basically see this model. This is a staff-picked model. This means that the staff from LM Studio really likes this model. And down here you get all the information. So here the capabilities once again. Then the model information itself. This is the exact name from the model. The format is GGUF with a new framework that also works really great for Apple Silicon chips. It has 24 billion parameters. Mistral is basically the company that made this. This comes from Europe. And the domain, it's of course an LLM. Then you see the download options. And the download option is here, this GGUF model. And we will find this most likely on Hugging Face. And you see, partial GPU offload is possible for me right now on my machine. And you always get the explanation from LM Studio. This model might fit partially in your GPU memory. This could often considerably speed up inference. There may be other factors that prevent it from loading, such as the model's architecture, model file integrity, or the amount of memory available on your computer. So you see, this model is generally speaking bigger than my VRAM. You know, I have 8 GB in VRAM. And this model is 15 GB big. So LM Studio immediately tells me that partial GPU offload is possible. Now let's just talk about GPU offload for a tiny bit. You already understand that these models, they need to run on our machine. We have the CPU and the GPU. And if we do GPU offload, of course it works a lot nicer for these LLMs. But I have only 8 GB in GPU memory, so I can do partial offload. So maybe like half of the model would run on my GPU and the rest needs to get handled by the CPU. This makes the model of course a tiny bit slower, and it's not 100% guaranteed that it works. And that's why LM Studio tells me like partial offload is possible. I want to show you a better example where we see some models that are too big for my machine, so definitely too big, and some models that are perfect for my machine. If you find such a model where partial GPU offload is possible, you can give it a shot, but it's not guaranteed that it works great. And here you also get to the README basically. And if you press download down here, you can download these models. If we come for example on this model, this has 36 billion parameters, and then you see it immediately. This is likely too large. This has 21 GB in size. And LM Studio immediately tells me, hey, like this is most likely not for your machine. If we come on Qwen 3 4B thinking, I would assume that this runs on my machine because this has only 4 billion in parameters. If we press on it, you can see that a full GPU offload is possible. So this means the entire model can get sucked in my GPU like really easy. This is only 2.5 GB big. And that's actually a model that I want to download right now because I think it works like really fast to download. In order to do this, we simply press download. So you saw a model that is too big. LM Studio immediately tells me that it's too big. If it's perfect, LM Studio tells me full GPU offload is possible, just like you see here. And if it's like a bit bigger than my VRAM, LM Studio tells me that a partial GPU offload is possible. Of course, you can also search here for models. If you come for example on GPT OSS 20B, you see we have here this model with 12 GB in size, and also here LM Studio tells me that a partial GPU offload is possible, so not the full GPU offload. I have already downloaded this model, and I will also show you this model basically in LM Studio. You can also close this down, and in the left lower corner you see that I am downloading right now a model, and the model is right now nearly fully downloaded. If I come here on my models, you will actually see that the model should get included here. Boom, now it comes. It's basically this small model right here that I have downloaded right now, and this model has tool use included, just like you know. What you can do right now is, you can come on chats, and here you can basically take all your settings, how you like them. You can search through chats if you already have a lot of chats. You can make new folders and name these folders, or you can simply make normal new chats. And before you can chat, of course, you need to select a model. In order to do this, you press on select a model to load. And then you can simply press on these models. Let's just actually use this really small model that we have downloaded right now. I do think it was this thing right here from Qwen. So if I press on these, I get immediately all the settings. So you can be really precise. The context length, it supports up to 250,000 tokens. So we can go up and down with this number exactly. And LM Studio immediately tells me estimated memory usage. You see here on the GPU will be like roughly 3 GB, and the total is also 3 GB. If I go up with this token, you see how much more GPU will get needed. And if I come like on maximum, LM Studio also tells me not enough resources to load the model with current settings. So simply use something that works great for you. I just run here with this 4000 tokens just to make a quick example. Then you see the GPU offload. Right now I have it at maximum capacity, but you can also go down, for example, with the GPU offload, leave the rest at the CPU, and then you can also increase the context window a tiny bit more. So you even have a chance to work with higher context windows if you do the GPU offload a little bit less and leave something on your CPU. But I would basically not recommend you to do this. If it's possible, use as much GPU offload as LM Studio allows you to do. Then the CPU fresh pool size, leave this how the settings are, and all the other settings. I would also recommend you to leave them how they are. We want to have the model still in the memory. We don't want to use a specific seed. You already understand the seed from diffusion models. Basically LLM have something similar, but it's of course not cool to always use the same seed. And you can also press here remember settings for this model if you think you have found great settings. And then you can basically press on load the model. And if you don't want to save the settings, you can also uncheck this box. Then we press load model. The model will basically get now sucked into my VRAM. Right now the model is loaded. And now I can chat with this model. If I type in hey, you see the model has also the test time compute. So basically the model is thinking and then it answers, hey there, how can I help you today? And the speed of this model is really fast. You see, all of this thinking was enormously fast. I get here nearly 70 tokens a second. So I cannot complain about this model, at least not yet. What you can do here is, of course, you can work with the standard prompt engineering. Besides working with normal prompts, you can also come down here to upload files. And if you want to do this, also the RAG technology will work. Let's just make a test here. If I press here and I upload this Doggo PDF, then you see that on these tools, so these are the tools, RAG gets included automatically. But I have to tell you, this is not like the real RAG. This is just in context RAG. LM Studio will basically can make summaries and similar things. You will not have an external vector database here included. So yeah, they call it RAG, but it's not really RAG. What you can do is, for example, make a summary of the PDF. And if you send it out, you get the summary. You can also ask specific questions and so on. They will also try to use an embeddings model, at least how I think they do it. So you see, chose context injection and so on. So here you see what the model did. It talked for 8 seconds. And then we get also the answer based on the provided PDF. Here is the whole summary. And I do think the summary makes absolutely sense. And you can also see from where this model pulled its information. Here you basically see the chunks that get inserted. So it's really easy and nice to upload a small amount of PDFs, but don't try to make a big RAG application here. This is for smaller PDFs. Then you can also come here to regenerate this message. You can continue assistant message. You can branch the chat after the message. You can copy the message. You can edit the message, or you can delete the message. What you can also do is, of course, take a new chat. And as soon as you are in a new chat, you can exclude RAG, for example. If you come on these integrations right here, you can also include a sandbox if you want to run something in a sandbox environment. And RAG, you already saw this. The model context protocol, like I told you, we will talk about this later because this gets a little bit bigger than you think right now. And if you are in a new chat, of course, you can also use different models. Let's just say for right now you want to use the GPT OSS model. Let's just take a look what LM Studio tells me right now. You see that the GPU that I use is right now 3.5 GB. And the model is of course 12 GB big. And why don't I use more GPU? Because LM Studio automatically does less GPU offload for me to run this model. I can try to increase this GPU offload. And you see that more and more gets sucked into my VRAM. And at some point, the VRAM will be, if I go up here to the full VRAM, I do think this will not work great. I would recommend you to play with the settings just like how LM Studio tells you. Most of the time they are a tiny bit conservative. I also found out that we can go up a tiny bit more. Let's just try to do like 5 GB in my GPU. I do think this is fine and the rest works over the CPU right now. Then the token window, so the context length. Of course, we can increase or decrease this, and this will also have an effect once again on my GPU usage here. And all the other settings, you already know them. As soon as I press load model, of course, I will use the new model in this chat. And now you see the model is loaded. And as soon as the model is loaded, of course, we can use it in this new chat. Something that is also really cool in LM Studio is that we can use the reasoning effort here. We can go up or down with this reasoning effort. I just want to leave this at low because while I am recording, I am sure that this will be really slow. Then you see also down here the RAM and the CPU. So basically, as soon as something runs hot, you can eventually see it here. If I type in hey right now and I send it out, the assistant will basically start to think. This will be, like I told you, a bit slow. Yeah, come on, I do think this is fine. Hey, how can I help you today? We have actually a run rate of 10 tokens per second, so I do think this is really fine for such a big model. And it runs so smoothly because LM Studio handles the right amount of GPU offload for me. This works actually a lot more efficient than in Ollama, so I would strongly recommend you to give LM Studio a shot. This has a really nice interface. You can set the system prompt and you can do basically the same thing as in anything LLM, but the only limitation is that you don't have like really rack included. This rack application is a tiny bit less cool, let's just put it this way, than in anything LLM, because you don't have like really a vector database included. But still you can do a lot of stuff and you can do more than in the normal Ollama app. And later, as soon as we connect this thing with the Model Context Protocol server, I do think that you have also advantages over anything LLM. You will see exactly what I mean, because we can include SQL databases over MCP, we can include vector databases over MCP, we can trigger sending mails over MCP, we can do a lot of interesting and cool stuff here. We have also the possibility to use OpenWebAI and a lot more. I want to give you all the cool tools that you can use so that you have everything in the arsenal and use the right thing for you. One last thing that I want to show you is, if we come for example right now on Developer, you see that a model is imported here. And you can absolutely use this model from different endpoints. If you are a developer, you are most likely familiar with curl. So you can simply copy this curl. I just open up, for example, a new text file. So new text file. And I want to show you what this curl is. This curl looks something like this. So you basically can connect via this curl and make a HTTP request to your local host here. You see the content type is an application/JSON, then the model is of course the OpenAI GPT OSS 20B model, and the message, here we have role system content, always answer in rhymes, today is Thursday, so this is a stupid system prompt. You can of course change the system prompt. You have the temperature, you have the max tokens, and you don't have streaming enabled. Of course you can make all of the settings right here in this interface. You can come here on the right side. If you come on info, you see the model information, then you can come on context. You can either select a preset or give the system prompt here. And here you see only answer in rhymes. You are a helpful assistant. So here you can set every system prompt that you want. So instead of the stupid you answer with rhymes, of course you can use this right here. You can save it as preset, for example. Then you can come on the interface. So here you have the custom fields. The reasoning effort is low, for example, but you can also put it to medium or high. Then you have your normal settings with the temperature. So if you go down with the temperature, also this will get changed in your curl. Then you have sampling, structured output, and so on. These are just the standard settings that you already know. And then you have load, of course. So you can also change the GPU offload and so on right here. And what you can also do is, of course, to connect anything LLM with LM Studio. If you find out, for example, that GPT OSS runs a lot smarter and faster over LM Studio, but you like the interface of anything LLM more, you can simply include this HTTP. You know exactly how and where to do this, just like you did with Ollama. And then LM Studio will be your endpoint, so you really have a lot of options here. And down here you also get the server logs, so you can monitor everything basically that happened here. So long story short, this was LM Studio. With LM Studio you can do a lot of things. It makes it really easy to download models, run models, and also play with GPU offload. RAG is not that great in LM Studio, I have to admit it, but LM Studio runs a bit more efficient than Ollama, and some people really love the interface. You can download your models, you can run them, you can also make endpoints, and the coolest thing is, you can connect to MCP. And of course we will do this a bit later in the course, because I do think you should also learn the basics of diffusion before we talk about MCP, because with MCP we can even include the diffusion models over MCP in these applications. So after this course you will be able to do a lot of cool stuff, and see you in the next video, because right now you understand the basics of LM Studio. We will come back to LM Studio once again later in the course as soon as you understand diffusion and also the Model Context Protocol, and then we will do some really fun stuff. In this section you have learned a lot. You understand how the RAG technology works. Basically, an LLM can call for help via function calling. And in this instance, it can call for help in order to get information. It does a retrieval. And in order to get this information, it makes a call to a vector database. In this vector database, there are vectors because you have stored them via the embeddings models. And you use a similarity search in order to get the most relevant documents. The top K results can vary between 2 and 8. Most of the time you use 4. Every document that you get is called a chunk. You can increase or decrease the length of the chunks. If you have longer texts, you obviously use longer chunk sizes. If you have a shorter text or mostly numbers and similar things, you use shorter chunks. But if you have only numbers or tables, you can also use SQL, and we talk about SQL later. If you want to optimize RAG with normal text, of course, you should make Markdown. You understand how this works. You can use llama parse, for example. Then we took a look at anything LLM. You can simply install the software, you know the entire interface, and you can build a lot of cool stuff here. You can simply connect to Ollama, you can set chunk size, different models for embeddings, and a lot more. Then you can upload documents, shift them to your workspace and embed them. And remember also to use a chunk overlap for better retrieval. It should be roughly 5%. You can control the behavior of the AI by setting a system prompt. You can give a role, some rules, the style, and a lot more. Even JavaScript variables with date, time, and similar things. Obviously, you can also increase or decrease the temperature for more or less creativity. And if you include memory, anything LLM will know for 20 messages about what stuff you are talking. If you don't include this, anything LLM will actually forget what you are talking about on every single message. You also saw an overview of the agent capabilities. Yes, we have also MCP included, but to be honest, this is not that great. You can eventually include the internet search, and also the slash commands. These are things that work relatively great. Then you also saw LM Studio, and LM Studio is a really great software. It makes it easy to run everything without Ollama. You have a nice interface, you can play with GPU offload. Always make sure that you are similar to the settings that LM Studio recommends to you, but you can try to increase the offload a tiny bit because LM Studio is a bit conservative here, and then these models will run relatively smooth. Also in LM Studio you can make endpoints, you can include the RAG technology, and you have also the possibility to include the model context protocol and a lot more. Obviously, you can also set system prompts. But we are not there yet for the model context protocol. We need to do this later, as soon as you also understand n8n so that you can build your own MCP servers. But still, for right now, I do think that you have learned a lot, and I want to tell you what learning is. Learning is same circumstances but different behavior. If you have not installed anything LLM or LM Studio yet, you have not learned. You need to play with these tools in order to get and grasp them. Only then you have learned. And I want to tell you once again really quick what really good learners do. Of course, they learn together, because more people always know more than few people, and we could reach this goal by you sharing this course. If you share this course and also the other person gets value out from this course, they will describe the value to you because you have told them. So thank you for that, and I'll see you of course in the next section, because in the next section we start to dive into diffusion. Diffusion is the second technology that you need to understand, and as soon as also the basics of diffusion are mastered, we can go into automation and also use the model context protocol. So I see you of course in the next section.